Hello there, geometry friends. Again, Mr. Stewart here, and we are going to do some practice with the partitioning segments and proportionality stuff that we did in the previous lesson. So we're on lesson 9, unit 6. Let's get right into it. Directed line segment AB has coordinates A at -9, 8 and B at 7, 0. Find the coordinates of the point that is 1/4 of the way from A to B. Personally, I'm a visual learner, so I like to draw myself a little sketch just so I know exactly what I'm looking at here. So if I just make A here, B over here, there's my segment. I want to go 1/4 the distance from A to B, so then I know that the point that I'm looking for, it doesn't tell me what letter to use, so I'll just use P for point, is 1/4 of the way there. That means there's one part here, 3 parts from P to B, and that way there's 4 parts total to the from A to B to the other end. So the steps and skills that we did yesterday, or in the last lesson, we found the change in x first. So that'll be x2 minus x1. That makes a 16. And then we had to do the same thing with our change in y, with y2 minus y1. That gives us the horizontal and vertical component of change from one point to the next. So that means horizontally from A to B, it's a total of 16 units. And vertically from A to B, it's a total of 8 units. The second step in this process was to use our scale factor and multiply it times that total distance. So if the total horizontal distance from A to B was 16 units, we want to go 1/4 of that distance. So we should count 4 units from A horizontally. And then vertically from A to B, it was down 8 units. So I want to go 1/4 of that distance vertically. So I should count down 2 units. Now I need to make sure that I'm counting from the correct point. So I just make sure I read the directions and read the question, and it says from A towards B. So I'm going to use the coordinates for point A and go from A. The x coordinate at point A is -9, and I'm going to add 4 to that to get -5 from my x coordinate. Again, from point A, my y coordinate was 8. I'm going to add the -2 to that to end up at 6. So then my final answer, point P, I named it point P, it's not named anything on your paper, is the point -5, 6. That is the point that is 1/4 of the way from A towards B. So why don't you pause it, try number 2 on your own, and then when you come back, we'll see if you did it correctly. Okay, so hopefully you paused the video, tried it yourself, and let's see how you did. First thing we do is like we did above, find the change in x and change in y. You have to make sure you do x2 minus x1 and y2 minus y1 in the correct order. If you don't do it in the correct order, then you're basically doing the wrong direction. You're not going from G to H, you'd be going from H to G if you had the order backwards. Then, once we have the change in x and change in y, we apply our scale factor of 2/5. We want to go 2/5 of the distance that we just found. So 2/5 of -9 means I would count -3.6 units in the x direction. That would be left. And then on a graph, I would count 6 units up because the y was positive. So I will go back to the fact that we are going from point G towards point H. So from point G, I add the -3.6 to the x coordinate, the 6 to the y coordinate, and then my results give me the partition point that we are looking for. So that point, 4/10, -1, is a point that is 2/5 of the way from G towards H. Now, every time we do these problems, the information could be given in a slightly different way. So let's take a look at number 3. Using the point G, which is at 4, -7, and the point H, which is at -5, 8, Find the point K that separates GH into segments such that the ratio of G to K to H is 1 to 2. Man, when I read that aloud, it sounds so confusing. Okay, so again, I'm a visual person, so I want to draw a picture. Because I'm given the ratio of 1 to 2, I need to make sure that I use the correct scale factor in my calculation. I don't know if it's going to be 1/2, 1 to 3, 2 to 1, so I'm going to get myself a picture to help. So we have G, we have H, we have coordinates for those. We are finding point K that separates GH so that G to K is 1 unit. G to K is 1 unit, but K to H is 2 units. That means from G to K, it's 1/3 of the whole distance from G to H. So that my ratio number, when I do my calculation, is going to be 1/3. So I take the 1 and the 2 and add them together. 1 part from G to K, 2 parts from K to H, give me 3 parts total. I want to go 1/3 of the distance from G towards H, from G to H. Okay, now we're all set to do our calculations. So, just like before, change in X and change in Y. After I do my change in X and change in Y, that was step 1 that we labeled yesterday. Step 2 is now to apply our scale factor. So I'm going to apply the scale factor of 1/3. So I need to do 1/3 of -9 for my X direction. And I'm going to do 1/3 of 15 for my Y direction. And then the third step in this process is to apply those changes to our starting point. In this case, we are going from point G again. From G. For both the X and the Y, we're going to go from G. For the X coordinate, obviously we use the X value. And for the Y coordinate, we're going to use the Y value. Those two results give us our answer. So our coordinate point for K is 1, -2. Okay, so now it's your turn to try. Pause the video, do question 4, and when you come back, we'll see how you did. Just to make sure that you're using the right numbers, we have point J, we have point K, and point P is somewhere on this segment such that 4 times JP is equal to PK. So 4 times JP is equal to PK. Which one's smaller? So whatever JP is, 4 times that would be PK. So from J to K would be a total of 5 parts, meaning your ratio to find point P from point J would be 1/5. So now that we have the right ratio, now you can pause it and go ahead and do the calculations. So there you go. Find the change in X, apply the scale factor, the ratio of 1/5, and then adjust the coordinates from J to get your new X value, and then follow the same steps to get to your new Y value. All righty, wonderful stuff. On to the next question. A robot begins its journey at the origin, 0.000, and travels along a straight path at a constant rate. 15 minutes into its journey, the robot is at the position point 3580. If the robot does not change speed or direction, where will it be 3 hours into its journey? Call this point B. So we want to find point B. That's the location of the robot after 3 hours worth of time. What we know is that it started at 00, and 15 minutes later, it's at 3580. So let's just do a quick little summary here. From 00 to 3580 took 15 minutes. All right, so we want to figure out where is it located after 3 hours. All right, so we got to do a little bit of figuring here. So let's figure this out. 3 hours, if I do 3 times 60, that is 180 minutes. So I know how far it goes every 15 minutes. So if I take my 180 minutes for the full 3 hours of time, divide it by 15, then I'll know how many of these distance intervals it will take to make a full 3 hours. So 180 divided by 15 is 12. So it's going to take 12 15-minute time intervals to make 3 hours worth of distance. Okay, so the change in x, 0 minus 35, or sorry, 35 minus 0, x2 minus x1, 35 minus 0, the change in x is just 35 units horizontally. The change in y would be the 80 units vertically. That's for every 15 minutes. I need to do 12 of those 15-minute intervals in order to figure out the location after 3 hours. So 12 intervals of moving horizontally 35 units and 12 intervals of moving vertically 80 units gives me the position for point B. X coordinate 420, Y coordinate 960. Now, if this robot continues past point B for a certain period of time, the amount of time we don't know, it'll travel an additional 3/4 of the distance it traveled during the first 3 hours, then it stops. How long did the robot's entire journey take? Okay, so let's read that again. The robot continues past point B. This is after doing 3 hours of time, it keeps going for an additional 3/4 of the distance that it traveled during the first 3 hours, and then it stops. How long did the robot's entire journey take? All right, so if it went 3/4 of the distance, traveling at the same speed, and its speed is constant, so 3/4 of the distance would also mean 3/4 of the 180 minutes, 3/4 of the time. So that means it's going to go an additional 135 minutes. So it traveled 3 hours and then an additional 135 minutes. So 180 minutes would be the 3 hours it started with. The 135 represents another 3/4 of that same distance. So that's a total of 315 minutes worth of traveling. So if our robot traveled 315 minutes, oh, that's what it asked for. It asked for how long. How long did the robot's entire journey take? 315 minutes. Now, if you divide that by 60, it wouldn't divide exactly evenly. It would be 5 1/4 hour, which would be 5 hours and 15 minutes. But it doesn't say what units we have to use, so either one of those is acceptable and just fine. Now, part C. what is the robot's final resting location? So where does it stop? Now we got to figure out the position point. Okay, so if we do similar to what we did at the beginning, we are going to take the total time of 315 minutes, divide it by 15, because I know how far it travels every 15 minutes. So that means if I figure out how many 15-minute time intervals it took, I can easily figure out where it stopped. So 315 divided by 15 is 21. So that means this robot underwent 21 15-minute time intervals from beginning to end. I know that it started at 0, 0, and it covers, remember what we did up here, covers 35 horizontal units every 15 minutes and 80 vertical units every 15 minutes. So horizontally, from 0, 0, 21 minutes worth of intervals at 35 units per interval gives us a location point of 735. For the y values, there's 21 time intervals of traveling. It goes vertically 80 units per time interval. Multiply that and gives me 1680. So then our final stopping point after 315 minutes is an x coordinate of 735 and a y coordinate of 1680. Now we know where it started, we know where it stopped, and it asks what was the distance the robot traveled in the last leg of its journey. Oh, not from the beginning, from the last leg. So that means the second portion. Well, we know from the work we did up here in part A, after the first 3 hours, our robot is located at point 429.60. Then there, it does the extra traveling, and then finally stops altogether at the position point 735, 1680. So we want to figure out how far was it on that last portion. So that means we're going to do the distance from the 429.60 to our final stopping point, 735, 1680. Okay, so you guys know the distance formula. Distance equals x2 minus x1 squared plus y2 minus y1 squared. Okay, so pause it, plug your numbers into the formula, and then round to the nearest integer. Plug your numbers in, go to your calculator, figure it out. So when you type this into the calculator, type it in without the radical so you can get the actual square root value, the radicand. Radicand is a fancy word for the number inside the radical. So it's 617,625. It says round to the nearest integer, so go ahead and do the square root of that. Round to the nearest integer, 786. That is the distance. Now we don't know what units we're talking about, so we'll just say 786 units. Okay, that was great. Fantastic. A lot of fun, a lot of fun. All right, so I think you're good to go. I did almost half of this, almost 2 pages with you. So off you go and practice. You're going to actually not experiment. You're going to revisit information that we did a couple units ago about the centroid of a triangle. Hopefully, once you get to that point, you'll remember what a centroid is, what it does to the segments, bring back some median memories. We'll see how it goes. Reminder, pull the answer key up, have the answer key right in front of you as you're doing these questions, because looking at the answer key will help you make sure that you're doing it correctly. If you get stuck, I'm not standing next to you to look over your shoulder and tell you how to fix it, but my answer key will silently do the same. So Thank you for coming. See you soon, and take care of yourself and your loved ones. Bye-bye.